Hi guys, and welcome back. My name is Trevor Sullivan, and thanks for joining me on my channel. If you are not yet subscribed to my channel, please consider subscribing to my channel. And if you like this video, leave a thumbs up so that I know that this was something valuable to you. And please feel free to check out the other videos on my channel as well, where I am providing lots of different types of tips for software developers, ranging from writing code to using Docker containers to leveraging cloud services on AWS and things like that. One other thing I wanted to mention as well is that my primary day job is actually a software instructor, a full-time software instructor at CBT Nuggets. So if you head over to cbtnuggets.com, I've actually published a lot of different training content over there on a lot of the similar topics that I talk about on my YouTube channel, anything from AWS to Azure to containerization to open source technologies to facial recognition and much more. So you can actually sign up for a free account at CBT Nuggets. We have a free account that allows you limited access to some of our training content, so you can kind of get a feel for the type of content that we offer. So please do consider going out there and subscribing. Anyway, that brings us to today's topic, which is going to be something a little bit different than what I've done in the past, where I'm basically just going to step into a PowerShell terminal and we're going to do some data analysis on a data set that's publicly available. I actually came across this repository over on GitHub Gist, or gist.github.com. A guy named Curran Kelleher had published this README file in which he linked to and actually took a static snapshot as well of an API from what appears to be NewYorkTimes.com, NYT.com here. And so basically there's a large JSON file here that contains results from the United States 2020 presidential election. Now, I'm not necessarily vouching for this particular data source. There may be inaccuracies in this particular data source, but considering that it's some free data that we have to work with here, I thought it would be a valuable example for us to kind of work through and take a look at how to explore a kind of random data set online. So as you can see, there's two different files in this GitHub gist here. There's basically just this README that has a link to the original data source where we can get the most up-to-date data. So I'll just right-click and do copy link address on there. And then separately, we've got this president.json file, which I believe if we were to take a look at the raw file, it's basically going to be a very, very large JSON file that contains a snapshot in time from the data at this particular URL. So instead of downloading president.json directly, which was taken 17 days ago, I'm actually going to just download the data directly from the API instead. So it's nice that if that API was to go non-existent or something, then it's nice to, I guess, have the backup option of taking this particular snapshot here. So what I'm going to do now is switch over just into my Microsoft Windows terminal here. I'm running Windows 10 locally here. And I'm running, as you can see here, PowerShell version 7.1.0. And PowerShell 7.1.0, as you probably know, is cross-platform, so you can run this on macOS or Linux natively as well. In fact, if you're running Ubuntu Linux, there's even a snap package, which makes it really easy to install. And if you're on Mac, you can use Homebrew to get it installed. I would really encourage you to check out PowerShell if you haven't yet had a chance to do so. It's an incredibly powerful object-oriented shell. Now, the first thing that we need to do in PowerShell here is to download the data file that we want to work with. And to do that, there is a command that's built into PowerShell. It's been around for a long time. I want to say all the way back maybe to version 3.0 or 4.0. I can't remember exactly when it was added, but it's called invoke web request. And if you just do help on it, or help is actually short for get-help, that's the full command name. And then the name parameter allows you to specify the command that you want to get help for. So basically, this just shows you the documentation that's built in for this particular command. And as you can see, there are several different syntaxes here that are broken apart by these line spaces. And PowerShell has this, PowerShell commands, PowerShell functions have this concept called parameter sets. So basically, you can have a single function that takes different sets of parameters depending on what you're trying to accomplish with it. Now, it's not always obvious immediately which parameters are actually different between the different parameter sets here, but we're just going to be using a really basic version of this command anyway, so don't worry too much about the parameter sets. Basically, what we want to do here is specify the URI parameter, which is going to be the URI to the file that we want to download. And then there is another parameter here. I'm just trying to kind of visually scan for it here really quickly. Here it is. So it's an optional parameter called a -out file. And what this allows you to do is if you want to download a file locally and you're not trying to do like web scraping or something like that to like scrape data off of a actual HTML page, then the out file parameter allows you to specify a path on the local file system where you'd like to download the file to. So those are the only two parameters we really need to worry about at this point. So I'll do invoke web request -URI, and then I'll do Control-V to paste in my URL there that I copied. And then it looks like the file name from this URL is actually president.json. So that kind of indicates to me that it's just a single large JSON file. And so I'm just going to spit it out somewhere on my file system, and we'll call it president.json. But you could honestly just call it whatever you want, maybe like data.json. And then what that's going to do is it's going to download the file. And then if I do a get item, which is kind of like how you do ls, actually it's more like get child item -path data.json. Now we can see we've got this file here. The length or size in bytes of that file is 6 million bytes, so 6.3 megabytes basically in size. So it's a fairly large JSON file. So the first thing that you want to do to process a JSON file in PowerShell is to read the file from the file system. Now PowerShell has many different ways of accomplishing the same task. So this may not be your preferred way of accomplishing this task, to read the file from the file system. However, PowerShell does have a built-in command called getContent that allows you to do that. Another way that you could do that is to do system.io.file : read all text. And basically what this is it's a static method on the file class in the system.io.net namespace, and you can go look up the documentation for this if you're interested. But basically that file class has a static method, meaning you don't have to instantiate the file class, basically just a static method that's built onto that class directly. And it accepts a file system path as well as an optional text encoding. So that's one way that you could actually just read text from the file and then process it in PowerShell. But I'm just going to use the kind of PowerShell way of doing things, which is to use getContent. So I'll do getContent-raw, and I'll show you why in just a moment here. And then -path is going to be the file system path to my JSON file that I want to read. Now, what is this raw parameter here? So when you're retrieving the contents of a file, so you're just reading the file off the disk, by default, PowerShell will actually read a text file as multiple lines of text. So it'll actually take line breaks and it will give you back an array of strings. So if you had like a CSV file, for example, where each new line is a new entry in a CSV file, PowerShell would basically return each line as a separate array element. But I want just one massive string containing all of the JSON content. So to do that, you would typically just do -raw, and that will prevent the getContent command from splitting up that file on line breaks. Now, I don't actually know if there's any line breaks in this JSON file, but just to make sure that I don't encounter that issue, I'm just going to use the raw parameter. So if I just hit enter and run that command, you can see it's basically just going to spit back a ton of text, which is the entirety of this particular JSON file. Now, this is not particularly useful because I haven't stored a reference to the content. So in order to do something with the content, I now have to read it again. So what I'm going to do is basically store this data inside of a variable, and I'll just call it, let's say, data, for example. So now I've got a variable, and if I pipe it into getMember, you'll see that if I scroll up here, the type name, the .NET type name, is a system.string. So the system is the kind of root namespace for a lot of common classes in the .NET base class library. And then the string is a struct that is inside of that, or it might be a class. I forget if it's a class. I think it's a class. But the string is a class inside of that .NET namespace, which is system. So I can see that there's basically all these different methods and properties on the string, but what I want to make sure is that this is not an array. I want to make sure that it hasn't actually split this file on line breaks. So what I can do, I think, is say variable dash is. So this is basically a comparison operator saying, is the variable on the left-hand side of this operator an array on, or basically any type, or I could change this type over here to say, is it a string? And I actually get true. So is it an array? No, it's not. Is it a string? Yes, it is. So basically I'm good to go. This is one massive singleton string. Another way that you can do that as well is to look at the count property, which is built onto objects in PowerShell. And it basically, if it's an array, it's going to have typically more than one element. There's some other ways that you can do array checking as well. But now I know that I have just one massive string. And what I want to do is parse this string as JSON. So I want to basically take these JSON objects and convert it from just a text representation of this data into an actual PowerShell object. So to do that, what we'll do is we'll take our data string and then we'll pipe it into a ConvertFrom-Json command. And I'm actually going to overwrite the data variable. So I'm going to take that string, I'm going to convert it from JSON into a PowerShell object, and then I'm going to assign that result back to the data variable, which is going to effectively overwrite the string that's in data. So now data is no longer a string. As you can see, if we do data is string, it's false because it's no longer a string. However, if we just emit it, you'll see, or actually let's do get member here. And you'll see that we have this thing called a system.management.automation. That's the .NET namespace, or they're actually nested namespaces. So you have this parent namespace system, then management, then automation inside that. And inside of this automation child namespace, we have a class called PS custom object. And basically a PS custom object is just an arbitrary object. If you're familiar with languages like JavaScript and other dynamic languages, it's basically just a generic object. It can have properties and functions associated with it. It's basically just a generic object. But what you'll see is that the ConvertFrom-Json command has actually given me properties on this object that represent the properties in the JSON file. So if we were to actually open up that JSON file and look at the first few characters of it, it actually has a data property which points to an array of JSON objects, which contains basically all the data. So there's two properties here at the root. There's data and there's meta. So if we do data.meta, you'll see that there are some useful fields here to basically confirm when is the last time that this president.json file was updated. So we can see it was actually updated today at 6:50 p.m., which I presume is probably UTC time. It's probably Greenwich Mean Time, not local time, of course, because this doesn't know where in the world you're located. And then the track here is basically saying that we're tracking the presidential race that happened on November 3rd. And then the file also has a version. So I presume this is just kind of incrementing over time. So if we were to check back maybe in an hour or 2 hours from now, or maybe tomorrow morning, then this version number would probably increment. You could basically look at an old version of the file and say, is this version number different? Is it older or newer than this particular file? Or you could use the timestamp to do that. Either way should theoretically work. I'm not sure what the semantics of their internal versioning mechanism is, but just be aware that that version number is there if you need it. Now, let's take a look at kind of the meat of this file, which is going to be the data itself. So this data variable, this JSON object that we have at the root, has a data property. So if we do data.data, we can now, actually let's pipe that into get member as well, so we can kind of introspect and look at this variable and see what child properties are actually contained on it. And as you can see, it actually has 3 different child properties here. So I'm just ignoring all these methods. You could actually just do get member dash member type properties, and that'll get all the different types of properties. PowerShell has a few different types of properties that are available, but these are just called note properties, which basically means that they're static values. And so what you can see is that we have 3 properties. We have live updates, party control, and races here. So live updates is kind of self-explanatory. I think that kind of indicates that there's live updates being done by the New York Times that are being provided here. So let's actually just inspect that really quick. So I'll do data.data.live updates. And as you can see, PowerShell actually allows you to autocomplete by hitting the tab key, because it knows what properties are on each of those child entities within this JSON structure. So one of the nice things about PowerShell when you're exploring a JSON file, or even CSV for that matter, is that it knows what properties are on each object. So this is basically a massive array, and if I spit out the whole thing, it's not very useful. So what I'm going to do is actually kind of like peek at the first object in this massive array. So actually one thing that you can do is do .count like we talked about a minute ago, and we can actually see that there are a total of 676 live updates in the latest version of this particular file. So what I'm going to do is basically peek into the first one and just kind of inspect it and see what the structure of these update objects looks like. Now because there's no data schema associated with this JSON file, at least that I'm aware of, there is technically a technology called JSON schema that allows you to basically bind a particular schema to a JSON file. However, I'm not aware that this particular file even has that, and even if it did, I don't believe the PowerShell commands will actually do any verification there. So all of these 676 objects within live updates could potentially have totally different properties on them. You know, this one has ID, another object might not have ID. So I'm going to basically assume that all of these objects have a similar data structure, but that there's nothing enforcing that because it's just arbitrary JSON data, right? So let's maybe inspect the second object, which is going to be array index number 1. Okay, that has ID as well. But if you take a look here, there's actually this property that I noticed, the second property. At the very top, we have ID, and then we have include on homepage false. So this newest update was not included on the homepage, but this one here was. So I can already see that there's actually a difference between these two different object structures. So yeah, we basically can't guarantee that they're all going to be the same. Now, there might be some common properties that you'll see across all of them, like maybe ID, or maybe text, or maybe winner, things like that. But you know, as a general rule, just don't necessarily believe that there's going to be a match between the schemas here. So this is kind of cool. So we've got basically these live updates coming in. So we've got the date and time of the update, which is a big integer value, right? And anytime that you see a date and time that's a big integer value, that's probably a good indication that it is a Unix timestamp. So it's basically a relative number based on the Unix epoch, which I believe is like 1970, January 1st at midnight. And so basically we can decode this as a Unix timestamp and see what we get. So let's try that now, actually. Let's just double click this and then just do a Control-Shift-C to copy that value. We'll do get date, and PowerShell has this cool Unix time seconds parameter, so you can basically take a Unix timestamp and then retrieve an actual .NET system.datetime object from that. And what you'll see here is that we get this exception saying that the argument that we passed in is greater than the maximum allowed value. And the reason for that is probably because the parameter here is Unix time seconds, and the actual value that the API or the data that we're looking at is providing is probably in milliseconds, not seconds. So what we actually need to do is take this value and divide it by 1000. I'll just wrap that in parentheses to make sure that it processes in the correct order. And what you'll see here is that this update was actually provided at 11:34 a.m. Again, I'm presuming this is UTC time because there's no time zone offset, basically. But this update was basically provided on Friday. So if I was to actually go look for this update, David Valdeo, Republican in California, and if I go out to my browser and just do a search for his name to see if there's actually any news here. Oh yeah, sure enough, looks like 2 days ago, there was actually some news. So it looks like I got that decoding correct by converting it from milliseconds to seconds and then interpreting that as a date time field. Now what's cool, because PowerShell objects are dynamic, is that we can actually take all of these properties, or sorry, all of these objects under live updates, and what we can do is dynamically append a more user-friendly date time, which is this right here. It's a system.datetime object that has lots of useful properties like the day of the week, month, the year, hour, minute, second, etc. And so then we can actually sort based on that. Granted, you could sort based on the Unix timestamp as well, but that Unix timestamp doesn't really have much human readability to it. I can't just like look at this integer value and infer that, oh yeah, that's Friday, November 27th. So what we can do is basically go to this array, data.data.live updates, of which again there's 676 objects. And what we're going to do is pipe this into a, what I think I want to do is pipe it into a for each loop and then do add member. Actually, I can just pipe it into add member directly because it'll treat it properly. And so what we're going to do is take each of those 676 objects, and for each of them, we're going to add a script property. So this is going to be a calculated property. And then the name is going to be PS date time. So we don't want to overwrite the date time that's provided as Unix timestamp. We're just going to add a new property called PS date time. And the value, see how we're going to add a script property here? Well, basically, we can write a PowerShell script that calculates a property for us. And so what we can do is do this.datetime divided by 1000, and then we can actually, you just do shift enter to put that on a new line here. And then we'll do that get date command dash Unix time seconds, and then just pass in the date time value for each one. And so that doesn't return any results, but what it did in the background that you don't see is that it actually appended a new property onto each one of these objects. So now if we inspect the first object in this live updates array, we actually have this property down here at the bottom called PS date time, which has the what I presume is the UTC time that corresponds to the Unix timestamp here. So we've actually adapted this object to have an extra property that's a little bit more useful for us. And so because that property exists on all of these live update objects, we can now sort the entire array. So we'll sort based on PS date time. And then let's maybe just select a couple properties. So we don't want all the properties, but we'll do PS date time and text, let's say. And then we'll just take the dash first 10. And so this is going to provide us the 10 oldest updates, it looks like. But if we sort descending, so I'm going to do sort object dash descending, and that will actually give us the 10 latest updates instead. So we were looking at the feed from oldest to newest, and by doing descending, we're looking at it from top to bottom, from newest events to oldest events. And as you can see on election day, there were actually a lot of updates happening, minute by minute here. But now that the election is kind of moving forward a little bit more slowly, we're actually seeing much more sparse updates here. So we saw one on Friday, one 4 days before that, another one the same day. Then 3 days before that, there was another update. So it's a lot less frequent here. So, so that's kind of a cool way to work with chronological data, where you're trying to sort it to see either the latest or the oldest data, or maybe somewhere in the middle. Maybe you could say, show me all the live updates where, where filter PS date time is greater than, let's say 2020-011-0 maybe 10, and PS item dot PS date time is less than 2020-11-12. And for some reason, yeah, because I have to convert that to a date. I was trying to just do a text-based comparison here, but what this is going to do is it's basically going to show me how many updates. It's going to show me all of the updates that occurred between the 10th of November and the 12th of November. So you could actually slice data now using those date time objects by saying, I only want, updates from, let's say, 14th to the 16th. and it looks like there were no updates there. Okay, there, till the 20th. And so there were a few updates there between the 14th and the 20th. So that's kind of cool. Just kind of shows how PowerShell's adaptive type system works, shows how to sort data and stuff like that. Let's drill into a different section of the data because I'm kind of dragging on too long about that. So let's take a look at data, and then .data, and then .races. So if we do get member here again, you'll see we've got this party control. I'm not sure what that is. Let's take a look at the races property though, which is also an array. I'm just going to see how long that array is. It looks like it's 51 array items in there. And if I take a look, let's just say at the first one here, let's see what this data structure looks like. So I'll scroll up to the top here. So it looks like the first property is race ID, and it looks like this is an abbreviation for the state of Alaska. Maybe Alaska, general, presidential, and then the date of the election. So yeah. Alaska, president, general, 2020, yeah. So basically, it looks like we've got the election date, the election type, the race type, obviously president, office of president, state name, capitalized, state name slug for URLs. We've got a lot of different properties here. We've got the winner. We've got the percent reporting here. We've got reporting display, so 100% reporting. Not sure what EE is. Edison data source. So it looks like maybe some other data source there. Now we've got a property here that contains candidates. And then we've got, oh, this is actually really useful here. We've got a county's property as well. So we could actually drill into this object for Alaska and take a look at the county's subproperty and then do a count on that because that's actually an array. And check it out. It looks like we actually have 40 counties in Alaska. So that's interesting information. I didn't know how many counties there were in Alaska. 40 seems like a lot, but I guess that's what there is. And then what we can do is look for the county names, maybe. So let's scroll up through here a little bit. I see that there's this name property, but ED, like election district maybe, election district 10, something like that. That's actually not quite as useful as I thought. However, you can actually see the number of votes per district. So maybe what we could do here is take all the counties and then do format table and then grab the name and the, what did I say, votes property? Yeah, so there's a votes property here. And so that can actually give you an idea of which districts received the most votes. So maybe which districts are the largest based on how many votes they have. Now, unfortunately, that data is not sorted. So what I'm going to do is inject a sort object into the pipeline here. I'm going to say sort on the number of votes. And now right down here at the bottom, we can see that this, what I presume is election district 28 has the most votes at 12,736. And election district 40, again, I'm making an assumption here, has 4,590 votes. So this would be, I guess, the smallest district potentially by population, or maybe just the smallest voter turnout for some other unknown reason. So that's kind of interesting. Let's maybe take a look at another state, though. So if we go back to races here, a lot of data here. And then if we take a look at the race ID, maybe let's look at like California, for example. So I'm going to say, give me all the races where PS item.race ID matches CA. I'm going to say actually !CA just to make sure that the string starts with that. And sure enough, it gave me one object here. And let's assign that to a variable called CA. So CA equals that. And then at the end here, I'm going to put an index 0 because this where syntax is actually going to give us an array, even though there's only one element in it. So I want to make sure that it's not an array. So I'm actually just going to index into it and grab it, index 0. So now if I take a look at the CA variable, it contains the results for the presidential election in California. And the race rating here looks like solid Democratic. The result is we have a winner, and shows us the time when polls have closed. So it looks like on November 4th at 4 a.m. UTC, so that would be UTC -8, I believe. So it would have closed at 8 p.m. local time on the 3rd of November, which makes sense, I think. I'd have to double check that online. But then down here we have this candidates property again, and then we have counties here. So let's actually look at counties for CA, since these probably have actual names. So here's a county. This is the last county, named Yuba. So let's just do .counties.name, and this is much more useful than what was in Alaska. I guess Alaska counties don't have names or something. That's kind of odd. And so we've actually got all the names of our counties here. And so what we can do is, let's say, maybe look at the margin. So we've got the leader party here in, is it Yuba? Oh, this is Yolo County. And we've got the leader party ID and then the margin. So let's actually grab the name of the county, the number of votes, and then we'll grab the margin as well as the leader party ID. So let's try that. So we'll grab all the counties and then say format table dash property, name of county, margin 2020, leader party ID, I think it was, and then votes. Let's see. Yeah, so that gave us all 4 data fields here. And so now basically this is just showing us kind of a nice summary using the nice PowerShell format table command, which gives us a tabular view instead of what they call the list format here, where the properties are on the left and the values of the properties are on the right-hand side. I like the table view because it's just a little bit more logical to read for humans. And so what we can see here is we're basically sorted by alphanumeric based on the county name, it looks like. And so what we could do is I could actually look at the margin maybe and see which county had the highest margin. So which ones are either strongly leaning Democrat or strongly leaning Republican, for example. So let's try injecting a sort command here in the middle. We'll sort on property margin 2020 and pipe that back into our format table command. So on the top side here, the negative margin is indicating a heavy bias towards Democrat, whereas a positive value is indicating a heavy bias towards being Republican. And I believe that somewhere here in the middle, towards like 0, would be kind of a county that's kind of split evenly, more or less. So basically here we can see that the highest Republican vote is in Lassen County, California, and the strongest Democrat vote, unsurprisingly, is in San Francisco County, or perhaps not surprisingly. I'm surprised that Los Angeles isn't more biased that way as well. But you know, the data is the data. I'm just reading it based on what I see here. This is kind of an interesting data point as well, as just seeing kind of which counties are most heavily biased. Anyways, this video is getting a little bit long, but I wanted to just kind of pick through this data and show you the data structures and show you some PowerShell commands that you can use to sort, filter, and slice and dice data. So I hope that this has been useful for you. Again, check out my training over at cbtnuggets.com and sign up for a free learner account if that's something that you are interested in. And leave a comment and let me know what's just one thing that you've learned from this video. I would love to hear about it. Head over to Twitter and follow me at PCGeek86, and you can visit my website at trevorsullivan.net. We'll see you in the next video. Take care.